Hello everybody, welcome back to the Statistics Fun Room. In our last video, we introduced the idea of a standard normal distribution, and we discussed the concept of where the standard normal distribution comes from, and we worked on the skill of finding area under the curve. And we discussed in that last video that we would use that to calculate probabilities of data that is normally distributed. So in this video, what we want to do is focus purely on the application of that concept, and I want to look at a couple examples of finding probabilities. Let's jump right into an example here. Through these couple examples that we're going to do together, I want to discuss how we would do this work by hand. And then we are going to look at a couple different pieces of technology that will help make our life a little bit more efficient. I did not want to have to take the time to write these problems out by hand, so I typed them up beforehand. Feel free to pause and write this problem down, and then unpause and come back and join me. So for this first example, we have the monthly utility bills in a city are normally distributed with a mean of $100 and a standard deviation of $12. Find the probability that a randomly selected utility bill is, and then we have A, B, and C here. The randomly selected bill would be less than $70, would be more than $140, and between 90 and 120. Alright, so I paused the video real quick and I wanted to put a little bit of space between these so I had some room to do some work. So for letter A, we want to find the probability that the randomly selected utility bill is less than $70. So I'm a visual learner, and I'm going to sketch a rough graph of a normal distribution. Now, if I'm plotting the raw data, right, my mean was 100 and my standard deviation was 12. So here's a z of 1, I'll add 12. Here's a z of 2, and then a z of 3. Right, remember that. Here's the z of 0, right, 1, 2, 3. So those are whole standard deviations away. And then negative 1, negative 2, negative 3 on my z-axis. See, 100 minus 12 is 88. And then I minus 12 again, and that's going to be 76. And then minus 12 again, and that's going to be 64. So again, z of negative 1, z of negative 2, z of negative 3. And again, in the prior video, we discussed that we could use the empirical rule to find probabilities when we fall right on these integer values of z. All the problems in the prior video, we looked at values that weren't on those integers, and we're going to continue that conversation here, right, with this application. So if I'm looking for the probability that a randomly selected utility bill is less than $70, I'm going to switch colors here again. So 70 should fall, somewhere around here. That should be my 70, and so I should be looking at the probability that I have a bill less than 70. So remember, we're going all the way down, all the way to the left, and I need to find that z-score, right? So I'm going to find the z-score. So the z-score is the data point minus the mean divided by the standard deviation. So I have my data point of 70 minus the mean divided by the standard deviation of 12. And that gives me a z-score of negative 2.5. So, symbolized, I'm going to find the probability with symbols that my data value is less than $70. That's equivalent to finding the probability that the z-score is less than negative 2.5. Remember, as we discussed in the prior video, the convenience to converting to z-scores is then I can use my standard normal table. So I'm going to pull up my standard normal table, and I'm going to look for negative 2.5. Now I need to go to the prior page here to look at the negative z's. So negative 2.50 is what I'm looking up, right? So the 0, the second decimal place, is in the last column. So I'm looking at negative 2.5. I'm going all the way to 0. I see 0.0062 would be the area of that shaded region. So I would have 0.0062 is the area of that shaded region. So the probability that my randomly selected utility bill is less than $70 is 0.0062. Letter B says what's the probability that a randomly selected power bill would be more than $140. So again, I'm a visual learner. I'm going to do a quick rough sketch of a standard normal distribution. I know my mean was 100 and my standard deviation was 12. So I'll just scribble over here to remind me that's my standard deviation. So 140, let me go ahead and find the z-score for 140. So let me switch to green, and I'm going to find the z-score, finding the data value minus the mean over the standard deviation. So my data value was 140. I'm going to subtract the mean and divide by 12. And that gives me a z-score of 3.33, rounded to 2 decimal places. And again, I didn't mention this in letter A, but my data tables, my standard normal tables, are typically to 2 decimal places, so I'm going to round my z-scores to 2 decimal places. Now, for this problem, we'll switch to red. We have a z of 3.3, so we're pretty far out here, a z of 3.33, and that is, my data point of 140. So we're looking for more than that price, right? So I'm looking for the area to the right of that data point. So my probability that my x is greater than $140 is equal to the probability that the z is greater than 3.33. Now if I pull up my table, let's remember that my table gives me areas to the left. So when I look up 3.33, in my table, that's the area to the left, so I'm going to have to do 1 minus that to get the area to the right. Now this is 3.33, so my second decimal place is 3. That's going to be my 4th column. So I'm going to go down to 3.3, 1, 2, 3, 4th column. I get 0.9966. Again, that is the area to the left, 0.9966. I want the area to the right, so I'm going to do 1 minus 0.9966, and that is 0.0034. I want to double check that value. Did I read that off wrong? So I got 3.3. So I wrote that wrong, right? That was 0.9996. I thought I wrote that down wrong. So let's just fix this real quick. 0.9996. 0.9996. So fixing my typo, 0.9996. 1 minus 0.9996 is going to be 0.0004. That is a really tiny area under the curve. That's a really tiny probability. If we think about this as a percentage multiplied by 100, I get 0.04%. Right? And if we think in terms of data, right, positions from the mean, a z of 3.33 is really far from the mean. Right? We had said any z's outside 2 standard deviation are called unusual because 95% is within 2 standard deviations. Within 3 standard deviations is 99.7% of the data. So outside 3 standard deviations, I'm within the 0.3% of data within my normally distributed data set of utility bills, any normally distributed data set for that matter. So some textbooks will call this extremely rare when I have a data point outside 3 standard deviations, or very unusual. Just depends on the terminology the textbook would use. Let's take a look at this last part of this first example. So we want to find the probability of selecting a randomly selected utility bill. What is the probability that that bill is between $90 and $120 per month? Again, I am a visual learner. You're going to hear that a lot. So here's my rough sketch. I know that my mean of 100 is in the middle. 90 is going to, roughly be here. 120 is going to roughly be here. Let's find those z-scores so that we officially know what those values are. So the z for 90 is going to be the data value minus the mean over the standard deviation. And then the z for my 120 would be, again, that value minus the mean over the standard deviation. Right? So here was 120, here is 90. Let me take out my calculator and crunch those values. I paused the video real quick, took out my calculator, For the data value of 90, I get a z of negative 0.83. And for the data value of 120, I get a z of 1.67. Again, rounding both of those to 2 decimal places. So here is my z of negative 0.83. Here's my z of 1.67. Now let me switch to red. Right, remember, this problem is asking for the area between those two data values. And what we talked about in that last video was that I would have to look up the area under the curve for 1.67. That gives me the data all the way to the left, and then I need to subtract out the data to the left of 90. So the probability, and I'm going to write this symbolically again, right? The probability that my utility bill is between 90 and 120, that's equivalent to the probability that my z-score is between negative 0.83 and 1.67. And we talked about, again, we have to find the probability that and let me go ahead and just use the z's here. Okay, find the probability that the z is less than 1.67, and then we're going to subtract the probability that the z is less than negative 0.83. So let's look up 1.67 in my table. So I have let's see, where's the 7? Here's the 7, and then 1.6 is right here. So I got 0.9525, 0.9525. So this is 0.9525, and then I'm going to look up negative 0.83. So in the table I'm using, right, the 3 and the second decimal place is right here. Excuse me, and I want negative 0.83, so that's 0.2033. Got 0.2033. And taking out my calculator and crunching that number, I'm getting 0.7492 as the probability that any randomly selected power bill is between $90 and $120 per month. This example illustrates really what this section is about, and what this video is about. Using the standard normal distribution, the area under the curve, interpreting that as a probability, and we're looking at the word problems to be able to apply this to something meaningful. So this next problem says that a survey at a local supermarket found that a shopper spends an average of 43 minutes in the store with a standard deviation of 12 minutes. The lengths of time spent in the store are normally distributed. And this is completely coincidental that the standard deviation of this data set was the same as the prior data set. So what I want you to do for me, I want you to pause this video, write this problem down, and I want you to attempt this one on your own without my help. When you're done, unpause the video, and then we will go through this together. So how did you do? Good. All right. Everyone's feeling confident. I like that. So let's take a look at this together. So again, I'm a visual learner, right? I'm told that this data is normally distributed. So I'm going to draw my normal curve. For this data set, my mean was 43 minutes, and my standard deviation was 12. I'm just going to scribble that up here so I don't forget it. Now, also remember that this is a z of 0, right? And then I have a z of 1, 2, 3, negative 1, negative 2, negative 3. So I need to convert my data points. So we're looking for more than 37 minutes, right? So let's find the z-score for 37. We have 37 minus my mean divided by my standard deviation, which is negative 0.5. Now again, I'm a visual learner, so negative 0.5 is going to be right here. And I want more than, right? So I want all the area to the left. So I'm going to look at my table. The table is going to give me, I said I want the area to the right. That would be the correct way of saying that. The table is going to give me the area to the left. I'm going to do 1 minus that, and it's going to give me the proper area. So again, symbolically, the probability that my data value, right, the randomly selected shopper, the time they spend being 37 minutes is equivalent to that as a z-score being greater than 0.5. All right, and before we move on, I'm just catching an error. I have a righto. It's not a typo. It's a righto. My z-score was negative 0.5, so I have no idea why I put this data point at positive 0.5. Let's erase that, and let's fix this issue. So here's negative 0.5. I want everything to the right of that. And this would be negative 0.5 here. So when I look at my table, I want to look up negative 0.5 as a z-score. So again, my table has the second decimal place of 0 all the way in the right column. So I have negative 0.5 all the way to the right. So 0.3085 is the probability to the left. So I have 0.3085 from my table. So I'm going to do 1 minus 0.3. Goodness, I cannot write. 1 minus 0.3085. And that is 0.6915. So for this last one, letter B here, again, I'm a visual learner. I got to draw my graph. So I have my standard normal distribution. And I'm looking for, let's see, my mean was 43, standard deviation was 12, and I'm looking for the probability that I'm between 20 and 30 minutes. So 20 and 30 are going to fall somewhere over here, right? We need to go ahead, let me make that green, and go ahead and find those z-scores. So the z for 20 minus the mean divided by the standard deviation, and then the z for 30. So again, minus the mean divided by the standard deviation. All right, I paused the video real quick, found those z-scores. So in red, right, I'm finding the area between those two z-scores. So just like we talked about on the prior example, right, I'm finding the probability that my random variable, my wait time, is between 20 and 30 minutes. That's equivalent to finding the probability that my z-score is between negative 1.92 and negative 1.08. I'm going to look these up in my z table in just a moment. Remember, I'm going to find the probability of z. I'm going to find the area of z all the way to the left, and then I'm going to find the area to the left of 20, and that's that area there, right? I'm going to subtract that out. So I'm going to find the probability that z is less than negative 1.08, which corresponds to my 30. And then I'm subtract the probability z is less than negative 1.92. So again, pausing the video real quick. I looked both of those up in my z table. I got 0.1401 minus 0.0274, giving me 0.1127. Now remember, this is the probability that I fall in that range. And we also are interpreting that as out of my entire data set, 11.27% of my data falls in that range. Now this question asked me, out of 200 shoppers, how many would I expect to be in the store between 20 and 30 minutes? So just scrolling back up to look at the verbiage, right? Between with 20 shoppers entering the store, how many would I expect between 20 and 30 minutes? This digital board doesn't always like me. So this is my percentage, 0.1127. Well, 11.27%, right, is how we would interpret that. But if I'm finding how many of the 200, I'm taking that percentage and I'm multiplying that to 200. So I'm going to take out my calculator and do that real quick. I got 0.1127 times 200. So that would be 20. I'm getting 22.54, right? So I'll say that that's approximately 23 customers. All right, so last thing I want to discuss is using technology. So we have a couple different pieces of technology we can typically use as we discussed in the last video. That would be a TI calculator, Excel, and then maybe a particular product that a publisher puts out like StatCrunch. So I'm scrolling back up to my first example, and let's check these numbers with our technology. So I'm going to use the TI calculator first. So I pull up my TI, and again, just like the last video, we talked about doing second vars, and that takes me to the distribution menu. And I want a cumulative probability, so I'm going to pick number 2. So I need to give the lower limit and the upper limit. And again, let me close this for a moment. All right, my lower limit would be all the way out here to negative infinity, going up to my value of negative 2.5. And what we did in the last video was we said negative infinity. I did negative 10,000. And then up to, what was that value? Negative 2.5. So negative 2.5. Now if we're doing z-scores, I leave the mean at 0, standard deviation at 1, and I click paste, and there's that value, 0.0062 that we have right here from our table. Now something that's cool about the technology is, if I go back to second vars distribution, and I call it number 2, it's allowing me to plug in the particular mean and standard deviation for this data set. So let me pull this down again. My mean was 100, my standard deviation was 12, and the raw data value we were looking at here is 70. So those are the things I'm going to type in. I'm going to go from negative infinity up to 70 with the mean of 100 and standard deviation of 12. So here's my negative infinity. I'm going to go up to 70. My mean was 100, my standard deviation was 12. So what the calculator is going to do for me, it's actually going to convert all of that to z-scores, and it's going to give me the answer. And of course, there's that same value. Now, when you're using this kind of shortcut version here where you can type in the mean and standard deviation, it just depends on the homework problem that you're doing, right? A lot of times homework problems will break these into steps, ask you to convert to z-scores. So you may need to go ahead and take that step to begin with anyway, but this is a nice, quick, efficient way to check our answer. If I'm using a tool like StatCrunch, I'm going to pull up Stat, I'm going to go to Calculator and go down to the normal calculator. Now, like we talked about in the prior video, if I'm doing z-scores, I'm typing in a mean of 0, standard deviation of 1. I'm doing less than, and that was negative 2.5. Is that what that was? Yes, negative 2.5, right, was my z-score there, negative 2.5. I can also do the same thing in StatCrunch, where I type in my mean of 100, my standard deviation of 12, and then I would just need to change that to 70 and have the less than, click compute, and of course, there's the same value. If I'm using a tool such as Excel, I'm going to click on a particular cell. I like to hit the function button, and I'm going to click over here and start to type normal. Well, what is it doing? It was all highlighted and I unhighlighted it. So I'm going to start to type normal, hit enter. Now remember, in the last video, we used this first option, and this says it returns the distribution with a mean of 0 and standard deviation of 1. So that is with z-scores. What I can do in this case is, where is it at? It is it this guy? No. Is it this guy? No. Here it is, norm.dist. Says to me it returns the normal distribution with a specified mean and standard deviation. So I'm going to go ahead and double click that one. So my x value was 70, my mean was 100, my standard deviation was 12, and I do want it cumulative to the left. So we can see there's that value. Now remember, this is everything to the left. If I wanted to do everything to the right, Excel doesn't allow me to change that. So let's discuss that here with our next example. So for letter B, I had more than 140. So if I bring Excel back up, if I come back up here and I wanted 140 as my data value, mean 100, standard deviation of 12. When I hit enter, that is the amount that was to the left. So with Excel, I'm going to come up here and do 1 minus that number, hit enter, and that is how much is to the right. 0.0004 was the value that we got here. Now, the cool thing about the calculator, let me clear this. If I do second vars and go to the distribution, call it number 2, I can change my lower bound to be the 140 that we had. Let me bring that graph up again. 140 was my lower bound. I'm going all the way out to infinity as my upper bound. So I got 140 as my lower bound. I'm going to pick 10,000 to represent infinity. Same mean, same standard deviation. paste, and there's 0.0004 in scientific notation. Right? This says move the decimal 4 places to the left because of the negative exponent. Using a tool such as StatCrunch, this is so easy, right? I change my data value to 140. I choose the greater than. It goes ahead and gives me that value. I didn't even have to click compute. And it's actually shading the area for me. I just can't see it. It is so far out. So lastly, to check letter C, I would be finding the data between 2 data points, right? The probability between 2 data points, the percentage of data between 2 data points. So if I bring, let's say, my StatCrunch back up, where was that guy? Here's my StatCrunch. So I'm going to click the between button, and then I'm just going to type my 2 between, oops, I don't change my mean and standard deviation. I type my 2 between numbers. What were those again? 90 and 120. So I have 90 and 120, and click compute, and there's that area, 0.7499. 0.7492 is what I'm getting here. So this is a great conversation to have. Technology like StatCrunch or the TI will sometimes give me values that are just slightly different. They're more accurate. What's in the table isn't as accurate. It also might indicate to me that I did a subtraction wrong, or maybe I looked up one of those z-scores and found kind of the wrong number there. But it is not uncommon to get a slightly different number at the 3rd or 4th decimal place. So I'm going to go ahead and check this real quick just in case I made an error. So I paused the video real quick. I checked to make sure I calculated the z-scores correctly. I checked to make sure I looked these up in the table correctly, and I didn't make a mistake. So the table is giving me these values, so definitely that confirms what I was discussing with you. There are times where the table gives you something slightly different than what the technology would give you. Now usually if you're doing like an online homework system, like something like my math lab or similar, they'll accept both answers. So they'll know that you may be using the table, they'll know you may be using technology, and both would be accepted in that case. So if I'm using something like a TI calculator, it's going to be similar. I'm going to go from 90 to 120. So my second, let me clear, get out of here. Second mode and quit. Second distribution, I'm going to call out normal CDF. My lower bound was 90. My upper bound was 120. And then my same mean and standard deviation. And this is 0.7499 if I round. So 0.7492 is what we got there. What we got from StatCrunch was 0.7499. So again, our technology is matching in that case. Now with a tool like Excel, it's not as user-friendly. I really need to find the difference between these two. Now I'm going to go ahead and use 90 and 120 in my Excel sheet, just like we did last time. So I'm going to hit the function. I'm going to do the normal dist. Right? This was specified mean and standard deviation, so let me double click. So my X value was 120 was the largest. The mean was 100. Standard deviation was 12, and it would be cumulative. I can see that value that's there. I'm going to click up here and say subtract. I can start to type normal dist, double click. The mean, the data value, sorry, was 90, comma, the mean was 100, standard deviation was 12, and I want that to be cumulative as well, and there's the 0.7499 again. So that really wraps up what we wanted to discuss in this section video, where we're applying the normal distribution, standard normal table, to find probabilities within some applications, some word problems. I'll see you in the next video.